Hello, good morning. Today is Monday, June 1st, 2020. And today we are going to be working on science. So please take out your student's book, your contract, and your pencil case. Are you ready? Excellent. Let's start. Please open the book on page 106. Exercise number 7. Label the photos, high-pitched or low-pitched. Check your answers with a partner. Then think of as many loud and soft sounds as you can. On the first picture, we can see some canaries. Then we can see a man drilling the ground. On the third one, there's a whistle. Here we can see a gorilla vocalizing. Then we can see a blue whale. And finally, there's a man playing the cello. Francisco, number 1, is it high-pitched or low-pitched? Yes, high-pitched. Jorge, the second one. Give me the answer, please. Yes, low-pitched. Andrea, the third one, please, the whistle. Yes, high-pitched. Alan, the next one. Yes, high-pitched. Then, Miranda, the whale. Yes, low-pitched. And finally, Laura, the man playing the cello. Yes, low-pitched. The answers look like this. Very good. Then, we are going to continue reading. It says, animals and sound. Many animals use sound in different ways. Some animals use sound for communication. Some animals use it to help them navigate or to locate objects. For example, dolphins and humpback whales use vocalization to communicate over long distances. Bats and dolphins use echolocation to locate and identify objects. That means they send out calls and listen to and interpret the echoes that return. Humans can learn to use echolocation too. Now, on your book you have 2 images, right? On the first one, you can see a wolf that is communicating with other wolves. And the second, bats use echolocation to navigate and hunt. Now please go to page 107. Lesson 3. What is light energy? Read. Match the photos to their descriptions. And the first thing that we are going to talk about is light. Light is everywhere. We get it from the sun, lamps, and cell phone screens. It can travel in straight lines, reflect off objects, and bend as it passes around or through objects. There are several kinds of light. The kind we can see is called visible light. You may know that light can pass through some materials and not others. Transparent materials let nearly all light pass through. Translucent materials let some light pass through, but not all. A material is opaque if it doesn't let any light pass through it. Light hitting an opaque object is either reflected or absorbed. And then we have these 3 words and 3 images. The first one, transparent, translucent, opaque. And here are 3 different pictures. The first one, you can see a lamp. The second one, a window. And the third one, some curtains, right? Now the first one, Melanie, transparent. What would be the correct photo to the description of this word? Yes, very good. The window, right? Excellent. Miranda, the next one, translucent. What would be the picture, the perfect picture for this word? Yes, the lamp. And finally, Aaron, opaque? Yes, obviously, the curtains, right? So your book is going to look like this. Excellent. Let's continue reading. Light waves and color. Like sound, light travels in waves that have certain wavelengths. Also like sound, the speed of light is different in different materials. However, light is different from sound in many ways. For example, light can travel through empty space. For you to see an object, it must give off or reflect waves of visible light, which must enter your eyes. Different colors have different wavelengths. When all the colors of visible light are mixed, the result is white light. If you shine white light on an object, some wavelengths bounce off it and some are absorbed. The wavelengths that bounce off can enter your eyes. They determine the color you see. Okay, turn the page, please. Let's continue reading. Page 108. Electromagnetic spectrum. Unlike sound, light is not a vibration of particles. Light is an electromagnetic wave that is a combination of electrical and magnetic energy. Electromagnetic waves can have very long or very short wavelengths. The full range of electromagnetic wavelengths is called electromagnetic spectrum. It includes visible light, but also short wavelengths such as those of X-rays and longer wavelengths such as those of radio waves. Heat. When you feel the warmth of the sun or the heat of a light bulb shining a few centimeters from your hand, you are feeling electromagnetic waves. Infrared waves feel especially warm. Warm objects produce more infrared waves than cold objects. And there in your book, you have 3 images, right? Okay, the first one, an infrared photograph shows that some parts of this house are hotter than others. Here, I have a lady, and you can see that some parts of her body are warmer than others, right? Then, you have a microwave oven. When food absorbs microwave radiation, its temperature rises. And finally, you have radio waves are used for radio, television, and astronomy. Okay? Then you have a wave over there. Yes? It's a wave spectrum. Look, low frequencies and the wave, the frequency is a little bit longer, right? Then radio waves, infrared, visible light, ultraviolet, X-rays, and finally gamma rays. These are the answers of your book. The first waves that we can see are the, yes, radio waves. Then microwaves. Then visible light. And finally, the X-rays. Yes? Okay, then you have a question. What type of light energy does sunscreen protect against? The sunscreen protects our skin, children. Yes, against ultraviolet energy. Very good. Now please open your contract. Week 3, Animals and Sound. What is energy? Okay, label the photos high-pitched or low-pitched. Okay, the first one, we can see a bird singing. What would be this one, Aaron? Yes, high-pitched. The next one, Gerardo. You can see a lady that is playing the violin. Yes, low-pitched. The next one, Laura. You can see a lion roaring. Yes, high-pitched. And finally, Andrea. This is a drum. Yes, high-pitched. The next exercise, answer. Vale, number 1. For what reason do animals use sound? Yes, for communication. Alan, number 2. Vocalization is used to blank space distance. Yes, Alan, vocalization is used to communicate over long distance. The next one, who's missing? Camila, echolocation is used to blank space objects. Yes, echolocation is used to locate and identify objects. The next exercise, match. Number 1, there is light. Number 2, the light we can see is cold. Number 3, light can pass. Number 4, transparent materials. Number 5, translucent materials let. Number 6, opaque materials do not. And on this side, you have the different options. Through some materials and not others. Some light pass through, but not all. Everywhere, visible light. Let any light pass through. Let nearly all light pass through. Number 1, Jorge, there is light? Yes, everywhere. Number 2, Susana, the light we can see is cold? Yes, visible light. Number 3, Lucia, light can pass? Yes, through some materials and not others. Number 4, Vale, transparent materials? Yes, let nearly all light pass through. Number 5, Melanie, translucent materials let? Yes, some light pass through, but not all. And finally, Hera, opaque materials do not let any light pass through. Excellent. So your exercise looks this way, 3, 5, 1, 2, 6, and 4. Next exercise. Circle the correct word. Francisco, light is different, equal from sound in many ways. Yes, different. I cannot circle, so I'm going to put it in red color, but you have to circle, okay? Circle the correct answer. Number 2, Jorge Maqueda. Light can travel through full empty space. Yes, empty, right? That's why it's different from sound. Number 3, Susie. Different color have equal different wavelengths. Yes, different wavelengths. Very good. Andrea, number 4. When all the colors of visible light are mixed, the result is white light or red light. Obviously, white light, right? Red light? No. And finally, Camila, if you shine white light on an object, some wavelengths bounce off it and some are reflected or absorbed. Yes, absorbed. Nice. Finally, fill in the gaps. And we have electromagnetic spectrum, X-rays, and light. Please answer this exercise, and then you check the answers. Pause the video, please. So this would be the correct answers. It is an electromagnetic wave that is a combination of electrical and magnetic energy, light. Electromagnetic spectrum is the full range of electromagnetic wavelengths. And finally, an example of short wavelengths are the X-rays. Pay attention to the instruction. List numbers 1, 2, and 3. You are going to write this sentence, obviously with the correct answer. 4, 5, and 6, this one. 7, 8, and 9, this one. 10 and 11, this one. 12 and 13, this one. Please, with the correct answer, like this. Light is different from sound in many ways. Thank you very much for your attention. Have an awesome and beautiful day. See you tomorrow. Bye-bye.